Let's practice writing a 2-column proof dealing with some congruent triangles together. Now, if you're interested in actually writing out the proof step by step with me, there's a link to the PDF in the description box below. If you just go ahead and click on that link and open it up, you'll see a bunch of resources that I've made, and you can find the answer key PDF as well as the blank PDF to this proof. Alright, if you're ready to go, let's get into it. First, we're told that segment JL is perpendicular to segment KM. Here's segment JL, and here's segment KM. Given that these two lines are perpendicular, we know that they meet at a right angle. So that'll be helpful for a little bit later. We're also told that segment JK is congruent to segment LK. That's this segment right here, and this segment right here. This should be helpful later because it looks like these two segments are corresponding segments to their respective triangles. Let's just go ahead and mark these two segments for now so we know that they are congruent for later. Now that we've looked at the given information on the diagram, let's see what we're trying to prove. It looks like we're trying to prove that triangle JKM, which is this triangle on the left, is congruent to triangle LKM, which is this triangle on the right. Let's go ahead and use our given information and write a logical 2-column proof to prove that these two triangles are congruent. As usual, let's just go ahead and start by writing our given information. And what I think we should do first here is use this information of the fact that these two segments are perpendicular and establish which angles are right angles. Because these two segments are perpendicular, we know that angle JNK, which is going to be right over here, that's going to be a right angle. Also this JNM, this is right over here, that's also going to be a right angle. Then we have this angle LNM, that's over here, LNM. This is another right angle. And then finally we have this angle KNL. So hopefully this just helps us spell it out a little bit and we can see clearly that these are the 4 right angles. We can justify this by the definition of perpendicular lines or segments because they create right angles. Now I know we're trying to prove that triangle JKM is congruent to triangle LKM, but I don't think that we have enough information to go ahead and do that right away. However, instead, I think we can start with 2 other triangles that we know a little bit more information about, and then hopefully use that information to deal with those bigger triangles. Now, can you see which 2 triangles that we might want to start with first? If you were thinking of triangle JKN and triangle LKN, those are the 2 triangles I was thinking of too. So for our third statement, let's just go ahead and say that triangle JKN and triangle LKN are right triangles since they both have a right angle. We can justify this by the definition of right triangle since all right triangles are going to have a right angle in them. So we established that these 2 triangles are right triangles, so maybe we can use the hypotenuse leg theorem to prove that these 2 triangles are congruent to each other. And because we were told that JK and LK were already going to be congruent to each other, these are the hypotenuse of each of these triangles. If we can just prove that either JN or this LN are congruent to each other, that would be a leg, or we could prove that KN is congruent to itself. Now, I don't know about you, but I think that saying that KN is congruent to itself is probably the easier one to go with. So for the fourth statement, let's just go ahead and establish that KN is congruent to KN. And we can say this by the reflexive property of congruence. Okay, cool. So we established that these 2 triangles are congruent to each other, and we also established that the hypotenuse of each of these triangles are congruent, as well as one of the legs of them. So if we know that they're right triangles and their corresponding legs and hypotenuse are both congruent, we can say that these 2 triangles are congruent to each other by the hypotenuse leg theorem. Alright, so now that we know that these 2 triangles are congruent to each other, we also know that each of their corresponding parts are also going to be congruent to each other. Specifically, the part that I think is going to be more helpful to us is the fact that JN is going to be congruent to LN. Let's go ahead and say that these 2 segments are congruent to each other, and we can say this by CPCTC, where corresponding parts of congruent triangles are going to be congruent to each other. So let's just go ahead and mark that so we know that these 2 segments are congruent. Alright, so why did we want to do that? I guess my thinking here is that if we can use that information to deal with this triangle over here of JMN, if we can say that that is congruent to this triangle of LMN, like this triangle right over here, then we can go ahead and say that their corresponding parts are also going to be congruent to each other. And if we can do that, then we could say that this segment over here, JM, would be congruent to this segment over here of LM. And if we could go ahead and also say that KM later on is going to be congruent to itself by the reflexive property, then we could maybe use this side to say that these 2 triangles that we're ultimately trying to say are congruent to each other are indeed going to be congruent. So that's kind of my thinking right now. So what I mean by that is let's see if we can prove that triangle JNM and triangle L and M are congruent to each other. So can we say that these two triangles are congruent to each other? Well, let's see. We already know that angle JNM is a right angle. We established that over here. We also established that LNM is also a right angle. We said that right over here. So we do have angles that are congruent to each other. Let's see, what else do we already know? We know that segment JN is congruent to segment LN. We established that right over here because of the CPCTC. They were corresponding parts of those triangles above. Can we say, I think we can say that NM is congruent to itself by the reflexive property. And if we have all that information together, I think we could use side angle side here. So instead of writing a new line for that statement, let's just go ahead and add this NM is congruent to itself. And we can establish that by using that same reason for the reflexive property, so we don't have to rewrite another line for this proof. Okay, so we know that NM is congruent to itself. So for the triangles that we're looking at, the corresponding sides or segments of NM are congruent to itself, as well as these corresponding angles, these right angles right over here. And we have this corresponding segments of JN and LN. They're also congruent to each other. So it looks like we have side angle side. From this, we can make the statement that triangle JNM is congruent to triangle LNM. We can say this by the side angle side postulate. Alrighty, so if these two triangles are congruent to each other, then their corresponding parts are also going to be congruent to each other. So I think the corresponding segments of JM here is going to be congruent to segment LM. That's going to be helpful for proving that these two triangles of JKM and LKM are congruent to each other. And so for this statement, let's go ahead and say that segment JM is congruent to segment LM. And we can justify this by CPCTC, or the corresponding parts of congruent triangles are congruent. Alright, so I think we're almost there now. So remember, we're trying to prove that triangle JKM and triangle LKM are congruent to each other. And we were given that JK and LK were congruent to each other, and these are corresponding segments. And we were able to just prove just now that segment ML and segment MJ are also corresponding parts that are congruent to each other. Now think about it to yourself, what would you use to prove that these two triangles are congruent to each other? If you were thinking about using side, side, side by saying that this segment of KM is going to be congruent to itself, that's what I was thinking too. Let's actually go ahead and add that to this line over here so we don't have to add another line to our proof. So I could add that information to this line over here, but I have some space. I'm just going to go ahead and write that for step 9. And so for step 9, let's just say that segment KM is congruent to segment KM, similar to what we did in step 4 for both of these statements. And we'll just use that reflexive property again. And in the future, if you wanted to just go ahead and write all of these together, feel free to do so and condense that if you know that you're going to maybe use that reflexive property more than once. Alrighty, after all that, I think we're ready to prove that these two triangles are congruent. So finally for step 10, let's go ahead and say that triangle JKM is congruent to triangle LKM. And we can say this by the side, side, side theorem. So that first side, we were actually given in the very beginning. We knew that JK was congruent to LK, and those are corresponding parts. The second side that we found was that JM was congruent to LM, and those are corresponding parts as well. So JM segment is right over here, and LM is right over here. So that was our second side. And the third corresponding side that we found were congruent to each other was that KM was congruent to KM, and that was a little bit easier to find just because of the reflexive property of congruence. Alright, so that wraps up this proof. Now, what was our strategy here? Well, we started off with the triangles that we knew more information about. We established that those two smaller triangles up top were congruent to each other. Then we used CPCTC to say that their corresponding parts were also congruent. Then we were able to use that to kind of hop down to these two triangles down here. And once we established that their corresponding parts were congruent after we found out that their triangles were congruent, then we could go ahead and deal with that big triangle at the very end by using each of their corresponding parts appropriately to say that the two bigger triangles here are indeed congruent. Now, if you found this video helpful, please show me the proof by letting me know in the comments section down below and giving the video a thumbs up. And also, if you have any friends or classmates who might also find this video helpful, please feel free to share it with them and help each other out. As always, keep with the great work that you're already doing, and I'll see you in the next one.